In this goal, we are going to be talking about Hess's law. Hess's law is another way to find enthalpy, or delta H. And Hess's law, it's an additive property. So if we look at this chart down here, you can see that we have enthalpy given off when I go from a 1 to a 3 step. So this is just a 1 step where I'm going from a level 1 to a level 3. Or I could do it in a 2-step process. So I could go from 1 to 2 and then 2 to 3. And notice that 1 plus 2 equals 3. So I could have a reaction that gives off a 1 as far as its enthalpy, and a reaction that gives off a 2. And they will add up to give us that level 3. So I could do it in 1 step, or I could do it in 2 steps. But either way, I'm going to get to this level 3 for its enthalpy. So when you look and do Hess's law problems, you need to take into account these 2 important concepts here. When a reaction is reversed, the sign changes. When an equation is multiplied by an integer, such as a 2, then the delta H is also multiplied by that same integer. So in other words, if you multiply an equation through by 2, you're going to multiply the delta H by 2. So we can take a series of equations and manipulate them and add them up, and then I can add up their manipulated delta H's and add those up to get the enthalpy of a target equation. This is a very simple example of Hess's law. So I have a target equation, A yields C, and I need to find out what the delta H is. And I'm given 2 equations to work with. So my first equation is A going to B, and my second equation is B going to C. So we want to be able to add these up so that they will equal A going to C. So how I do this is I ask myself 2 questions. First of all, is it on the correct side? So we are going to look at each of the species in our equation and make sure that they're on the reactant side or the product side to match the target equation. The second question I'm going to ask, is it the correct amount? All right, so let's look at our first species. So let's look and see what's going on with A. So which of the equations down below has A in them? Well, the first one does. And I'm going to match it up, and I'm going to ask myself, is it on the correct side? Yes. The target equation has A on the left-hand side, on the reactant side, and so this equation is also on the left-hand side, the reactant side. So I'm just going to use this delta H as is because that A matches up. Now let's look at the next one. So the next one is C, and C, I'm going to look at the next equation, and I'm going to ask myself the same 2 questions. Is it on the correct side? Yes, they are both on the product side. Is it the correct amount? Yes. So I do not have to do any manipulation of equations in this example. So I'm going to add these 2 equations up. So I'm going to bring down everything on the left-hand side or on the reactant side, and then I'm going to bring everything down on the product side, and then I'm also going to add up those delta H's. So my delta H's is a negative 25 kilojoules. All right, now we're not completely done. Is there anything I can cancel out? Is there anything that appears on both sides? This is called an intermediate, and your intermediate should cancel out so that you can get a target equation. So I can see that I have B on each side, and so my overall equation, when I add these 2 equations, is A yields C. And notice that matches the target equation, so therefore I know that this delta H of the added equation is also the delta H of my target equation. And so I'm done. So my target equation has the enthalpy of negative 25 kilojoules. And I get that by doing a 2-step process instead of just a 1-step process. And this happens all the time in chemistry. So you might be given an equation for, hey, this is the reaction, but it really doesn't occur in that 1 step. Instead, it will be a multi-step reaction, and that's just the overall reaction. All right, let's look at another one. And again, I'm going to ask myself the 2 questions. Is it on the correct side? And do I have the correct amount? So my target equation is here. So I'm going to look at every species in that target equation and match it up. So let's first come to our E. So the very first equation also has E in it. So I'm going to ask myself the 2 questions. Is it on the correct side? Yes, they're both on the reactant side. And then do I have the correct amount? And the answer is no, I do not have the correct amount. So I'm going to put a 2 in front of here and multiply everything by 2. Even my delta H is multiplied by 2. So that would equal a negative 10 kilojoules. All right, let's look at my next thing, my G. So G is on the product side, and I look down here and I have G on the reactant side. So this is not on the correct side. So what I'm going to do is rewrite this whole equation, but put the products on the left and the reactants on the right. And when I do this, my delta H changes sign. So now it's an endothermic reaction. It's a negative 20. All right, so it's now on the correct side. So now I have to ask myself the question, does it have the correct amount? And I do have the correct amount. I have 1G here and 1G right there. All right, so let's go ahead. Oh, one thing that we should do is once we rewrite it, we want to cross it out so that we don't get confused. So I'm now going to add these two equations. So I can bring everything on the left-hand side down and everything on the right-hand side down. And is there anything that I can cancel out? And the answer is yes, we can cancel out this 2F. And so overall, my reaction is 2E goes to G. And so notice that matches my target equation. And so therefore, my delta H, I can just add up. So I have a negative 30 kilojoules. So what I do to the equation, you need to do to the enthalpy to that equation's delta H. So my answer is a negative 30 kilojoules. And I did add them up just to make sure that everything works out, so that when I add it up, it does equal the target equation. If it doesn't equal the target equation, I would have to redo it and figure out where I made my mistake. Another way to do these problems is instead of bringing everything down and crossing out what's on both sides of the equation, is to look up in the equations and try to cross them out there. So you can see that 2E is part of my target equation. So I'm not looking to cross that out. But I see that my 2F is not a part of my equation. So is there another 2F I could cancel it out? And it is in that next equation. So I can cancel it out just in the up above. And then I have G as part of my target equation. So I can look up above and see what I can cancel out. So see what is not in that target equation and see if it cancels out. So instead of bringing it all down. So it's just kind of a little shortcut. All right, let's do a more complicated example. We have our target equation. And so I'm going to just go through each species and look at these three equations. And I want to add them up and so they equal that target equation. Let's go through each of the species. So we have the first one, CS2, and I'm going to match it up to this third one. And I'm going to ask myself the two questions. Is it on the correct side and do I have the correct amount? Well, it is not on the correct side. I want it on the reactant side. So I'm going to rewrite this equation. And I cross it out because I don't need that one anymore. And I do have the correct amount. So I have 1 mole for each. So I'm done with that one. Now, the next one that we have is oxygen, and I can see that oxygen's in both these equations. And so I'm going to skip oxygen from right now and try to make sure the other ones match up and then go back and look at the oxygen last. All right, let's look at the next one then, CO2. So CO2 is only in this top equation, and I see it's at the correct side, and I also have the correct amount. So it's 1 and 1, so I'm good. And let's look at the SO2. So the SO2 I see is in the middle equation, and it has the correct side, but I do not have the correct amount. So I want to multiply through by 2. So I'm going to put a 2 here, a 2 here, a 2 here, and I'm going to multiply this by 2. And I get a negative 593.6. All right, let's go back and look at that oxygen and I'm going to, it looks like, add them up. So I want to get 3 oxygens, and it seems that the oxygens are both on the correct side in both those equations. And I have a 1 oxygen in the first equation and 2 oxygens in the second equation. So those should add up to 3. So you won't always have 1 equation per species. Instead, sometimes you add them up. So let's go ahead and add this up. And let's see if we can cancel everything or anything out. So I have a carbon here, and I don't see carbon in the target equation. Is there a carbon on the other side? And their answer is yes. So there's one there. So I'm going to go ahead and just cancel that out. And then I know I have oxygen in my target equation, and I know I have CO2 in my target equation. So I'm going to leave that alone. Let's go to the next row. So I do not have 2S in my target equation. And on the other side, I do have a 2S right here. So that will cross out. Okay. So this is an intermediate that we're just going to cross out. And so it's not in the overall equation. And then I also have oxygen and SO2, but those are both in my target equation. So I think I've eliminated everything that I can. So let's go ahead and bring everything down now. So we have CS2 plus, and I'm going to add up those 2 oxygens, or 3 oxygens. And then I have CO2 and 2 SO2. So adding these 3 equations and changing their delta H's, I should, because I got the target equation, I should be able to add up those enthalpies and get my final answer. So my final answer is, let's add those up. They are all negative, so I have a 1,075 kilojoules per mole for this equation. So this target equation up here would have the same. Okay, let's do another problem so that you can get some more practice here. So here's our target equation. We have C2H2. That matches up with the first one. And I see that I have it on the correct side and I have the correct amount. So I'm just going to leave that one as is. Let's go to the next one. I have 2C. That matches up with this equation. It's on the incorrect side though, so I need to reverse it. So CO2, arrow C plus O, and that will also change the sign on the H. And let's ask ourselves the question, do we have the correct amount? And the answer is no. I need to also multiply through by 2. So 2, 2, 2. And this is multiplied by 2. And I get a positive 787 for that one. And I'm going to cross out my equation so I know not to add into it and get confused. And let's look at the next one. So we have H2, and it's in this equation, but it's on the incorrect side. So let's go ahead and flip it. And that will change my delta H to a positive 286. And do I have the correct amount? Yes, 1 mole and 1 mole. And I'm just going to cross that out. So let's go ahead and add these equations up. So we have equation 1 to add up, equation 2, and equation 3 to add up. Let's look and see if we can eliminate anything. So in that first equation, the C2H2 is in my target equation, so I'm not looking to eliminate it. But I do see that there's no oxygen on the left-hand side. So let's see if we can cancel that out. And I see that I have oxygen here and oxygen here. So 5/2 is 2.5. So my 2.5 on the right-hand side adds up to the 5/2. So I can cancel all the oxygens. So they match up. Let's go and look in this equation to the CO2. That is also not in our equation. So let's see if we can cancel that out. So 2 CO2, and I have a 2 CO2 on the left-hand side. So if they're on each side, then I can cancel that out. And then I have a water. So there's a water on the right-hand side and a water on the left-hand side. So I can cancel that out. So I think I've canceled everything out just by going through that first equation. Everything left should be the target equation. So let's bring everything down. So C2H2, arrow, 2C plus H2. And I know what my delta H is going to be in this for the target equation. And I'm just going to add all those numbers up. And I get a negative 227 kilojoules. So this is Hess's law. So a lot of reactions do not occur in just one step. They might be multi-step because there's a catalyst involved, or maybe an intermediate is made first, but those catalysts and those intermediates will be canceled out, and I can take and add them all up using the idea of Hess's law to get that target equation. So whatever the enthalpies are for all the equations you use, when you add them up, they should equal the enthalpy of the target equation when you add them up.